Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there is a point load 24 kilonewton. It acts at a distance of 5 meter from the fixed end. The total length of the beam is 8 meter. In this beam we have different moment of inertias. For AC the moment of inertia is 2I and for CB it is I. Now we are going to find the degree of static indeterminacy. In this beam, the number of unknown reactions and moments are 3. The available equilibrium equations are 2. The degree of static indeterminacy will be 3 minus 2. It will be 1. From the point B, let us release RB. You can see that from the point B, I have removed RB. So the point B becomes a free end. We know the formula to find RB minus delta L upon delta. To find both of them, we are going to use unit load method. In the unit load method, we have to make sections. In this beam, there are two different parts, BC and CA. So we have to make two sections, one in BC and one in CA. You can see that I have made two sections, one in BC and one in CA. I have made both of the sections at a distance of x from the point B. Now let us make a table. In the table, first let us enter the members. We know that there are two members, BC and CA. For both of the sections, the origin is B. For BC, the moment of inertia is I, so the flexural rigidity will be EI. For CA, the moment of inertia is 2I, so the flexural rigidity will be 2EI. The limit for BC is 0 to 3, and for CA, it is 3 to 8. Now we are going to find the moment M. We are going to find the moments from the point B. In this case, we have to follow left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us take BC. Up to this section, there is no load, so the moment will be 0. Let us take CA. Up to the section, we have only one load, that is the point load 24. It is acting in the clockwise direction, so that it will be negative. For the distance, we have to take this distance. This distance is x minus 3. So minus 24 into x minus 3. Now we are going to find the moment small m. For that, we have to remove all of the loads and to apply unit load in the direction of RB. About both of the sections, the unit load is acting in the anti-clockwise direction, so that it will be positive, and both of the distances are x. 1 into x, it will be x. Now let us find delta L. The formula is integration of mm upon EI dx. For BC, the value of moment m is 0, so no need to make the integration. We can directly apply 0. For CA, the limit is 3 to 8 and the flexural rigidity is 2EI. So instead of EI, we have to apply 2EI. For delta L, we will get minus 950 upon EI. Now let us find delta. The formula is integration of m square upon EI dx. For delta, we will get 539 upon 6 EI. In this equation, we have found both of them. Let us apply them. In this way, for RB, we will get 10.575 kilonewton. Now let us apply the rule sigma V is equal to 0 and find RA. Let us take a moment about A and find MA. RB is acting in the anti-clockwise direction, so that it will be positive and the distance is 8. The point load is acting in the clockwise direction, so that it will be negative and the distance is 5. Let us assume that MA is acting in the anti-clockwise direction, so that it will be positive. For MA, we will get a positive value. That means our assumption is correct. it is acting in the anti-clockwise direction. Here you can see the shear force diagram. To find the moment in the point A, we can use right hand side rule. In the point A, we have MA, which is acting in the anti-clockwise direction, so that it will be negative. To find the moment in the point C, we can use left hand side rule. RB is acting in the anti-clockwise direction, so that it will be positive and the distance is 3. For the bending moment at C, we will get 31.725. We know that the moment in the point B is 0. Here you can see the bending moment diagram. In this point, the moment becomes 0. This is the point of contraflexure. We can make a section in this point and find the distance. You can see that I have made a section in that point at a distance of x from the point A. We know that in this section the moment is 0. Using that concept, we can find x. Now we are going to end this session. Thank you for watching this video.